Okay. So it's 12 p.m. in Europe. It's a time to start our call today. Hello, everyone. It's a cloud study network again, and our friends here in the call. We have speakers for today. Prem is here, Zubair here, Mitlesh, and Tito is also here. So we will talk today about Kubernetes. That will be the topic for today. Not just Kubernetes itself only, but applied to the exams. CNCF or Linux Academy, no, not Academy, Linux Foundation exams. CKA, Certified Kubernetes Administrator, also CKAD, Certified Kubernetes Application Developer, I guess, is the full name. Let me continue. There it is. Here we go. You should see us now again. Yeah, so that's it for today. We will have a boot camp, so we will help you to prepare for the exam. We have a specific tasks called tasks, which Prem has prepared in advance. There are three.
Hello.
Yeah, hi Prem, we are live now. Yeah, we just launched the stream now. I just quickly introduced our speakers, and we can actually like have a self-introduction by the speakers. Prem, we can pass to you now. Just say a couple of words about yourself. What are you doing, and what's your relation to Kubernetes?
Okay. So, of course, myself, Prem, working as a lead DevOps consultant for an organization in Holland. Kubernetes, I have been working with Kubernetes for quite some time now, and used Kubernetes in a lot of my projects, and even in my recent projects, I have prepared a couple of labs for CKA and CKAD so far, and also did some sort of fun and with new stacks along with Kubernetes and stuff. So, right. Yeah, that's all about me in a nutshell. So,
Yeah, absolutely. I can only add from my side, Prem is not only advanced in Kubernetes, but in many other DevOps-related technologies, and we already had Prem in a few calls before. Thanks for your contribution, Prem, all the time. And now let's shift to Mitlesh. Mitlesh, tell us about yourself a little bit.
Hi, everyone. Good afternoon. My name is Mithlesh, and I've been working as a technical service manager in Bangalore. And I've been mostly working at builds and release and deployment areas. Recently, we've been onboarding our applications to OpenShift. So, to that sense, I have passed my CKA last year in September, and then moving on to OpenShift to learn more from the Kubernetes perspective. So that's what I wanted to help everyone out here on what I can share my knowledge on Kubernetes.
Yeah, that's great. Thank you. So Mitlesh is CKA certified. Prem, correct me if I'm wrong, you are both CKA and CKAD certified, right?
yes.
Champion. Great.
Yeah, I'm only CKA.
Yeah. Your Mitlesh is CKA currently. But who knows, maybe soon CKAD as well, right?
Yes, this quarter.
Great. Tito, let's move to you now. Say a couple of words about yourself and how you are related. What are you doing and how you're related to Kubernetes?
Yeah, thanks, Karen. Hi all. My name is Tirthankar Shingo. I am based on India. So I am a senior cloud and DevOps engineer based on the telecommunication company in Kolkata. I started my journey in Docker and Kubernetes 5 years back. So just now, 4 months back, I did my CKA certification, and currently working in that cloud and DevOps technology and preparation for that CKAD and CKS.
That's great. That's great. So you are CKAD certified, right?
CKA certified.
CKA certified. Great. So we have 3 people in the call who are CKA certified at least, and probably also aiming for the CKAD, those who haven't. Okay. Zubair, say a couple of words about yourself. I know you are helping us today in the call with organizational stuff. You will be in the live stream chat as well, watching over questions and helping people out. So feel free to introduce yourself. Thanks.
Yeah, thanks, Karan. Hi, all everyone. Hi, everyone. This is Zubair from India. I am having around a decade of experience, and right now in cloud ops, where I majorly contribute on AWS. So I am here to organize this bootcamp. So all the best for everyone. Thank you.
Thank you. Thank you. Meanwhile, message to everyone who is watching the stream. It's a live stream right now. We see what you write. There is a small latency between the call itself and the stream, so maybe like 10 seconds latency, but it's not a big problem. Anyways, if you will have any questions whatsoever, feel free to post into the chat. And now you can post also general questions to this whole event. If there are some blank spots for you, feel free to ask. We will try to address them either in the chat itself, or we will answer you like in the call as well. So saying that, Prem, give us an idea how we are going to proceed today. What's the agenda? What's the plan for today?
Okay. So basically, as part of this bootcamp, we thought about like covering a CKA as well as CKAD from the exam point of view, and we're gonna as well as gonna be like a lot of labs, and I can also share the repositories that I have created like a couple of scenarios, the exams, along with we will also give you an repo details where you can actually one cluster, and I'm going to show everything. And so what I have done is, so we have like a specific set of topic for each exam, right? And we have combined together, and we have like set of 8 topics, and each topic has a small amount of theory and good amount of practical sessions along with that, and we're gonna go with the journey. With I can also show you like what are the topics we're gonna cover. About core concepts. So basically, like what all the components we have in Kubernetes, and how each components are installed. And we're gonna discuss about pod, what is pod, and what is the functionality of pod in Kubernetes cluster. We're gonna discuss about state persistence, which is like okay, how you can save these in pod, and so which will indirectly we will also cover persistent volume, what is persistent volume, what is persistent volume climb, how that is related with your pod, and so on. And then we have multi-container pods, which is also kind of fun keeping for your both the exams actually. Because you may also get a question to launch an Init container. We will also see that. We will also cover something about liveness props, readiness props, and so on. And going forward, we also have as a topic 6, we're going to cover workloads and scheduling, where we will show like how you can manually schedule a pod, how you can create the static pods, and what is meant by temp toleration, and so on. And as part of topic 7, we're going to touch best pieces of service and networking. As topic 8, we're going to do some small troubleshooting, which will also help you to replicate it in the exam, right? So we're gonna tell you like, okay, what's a different scenario you can face during the exam and how you need to solve those things. Yeah. So totally 8 topics, and that's what we're gonna cover today. And if time doesn't permit, then we will have one more session. But I hope we can cover this 8 topics in one go.
Okay, sounds great. Just to give a visual feedback to the people, let me maybe just share the screen where we will have a list of these 8 topics for everyone to grab or like see, and I can then later post it also into the chat itself. So let me quickly share the tab. We have prepared an internal document just to arrange this call. And if you see my screen sharing now, you should see this topic which Prem just discussed. I will also make sure to post them into the chat so that people have it. Okay, doc. So Prem, you can feel free to continue if you feel so.
Yeah. Share my screen because I have created a rough diagram. Okay.
Sure. Take over the control.
Yeah, I'm doing it. Okay. So basically, this is kind of a rough diagram which will help us to understand the core concepts of Kubernetes in much more detail. So basically, we have Kubernetes system cluster where we have master and worker nodes. Of course, there is no harm in deploying your applications on master node itself because that is capable. But then in real time, it's not advisable, right? Because all your Kubernetes cluster related configuration will be there on the master. It is always good to separate those configurations from your application. And if you see here, I have clearly mentioned that in the master node is meant for creating a plan. So plan as in, okay, what needs to be done, and based on the plan, it can do the scheduling, right? So, okay, you do a kubectl apply or run pod, and then it will not immediately go and get deployed into one specific node, right? So the scheduler will say like, okay, there is some free space available, just go and deploy, right? And then we have monitoring, so which will keep on monitoring the state of the clusters and the nodes, the individual components where you will deploy your application for nodes, where you will run your application as a container inside and pod. Sorry, I got my vaccine day before yesterday. I'm still not 100%.
No worries, Prem. No worries.
Please bear with me. So when we speak about master node, so we have like 4, which is like etcd and key value data store, key value pair data store, and we have an API server and we have a controller. There are like multiple controllers, but just to keep it simple, we have controller, right? And on the node side, we have and also, so I also need to do this, right? So container runtime engines running in all the nodes. When we see about worker nodes, we have Cubelet, which is kind of a key thing in the worker nodes, which ensures that. And with Cubelet, you can also schedule your part inside the node itself. So let's say consider a scenario you don't even have master, schedule an application on worker node 1 or 2. It's still possible using Cubelet. I think we can cover that as part of our troubleshooting lab or else workload scheduling lab. Okay. And container runtime engine, we're going to use Docker. I'm going to show like how you can spin up your own cluster in a minute. Before that, so we have like 2 important components on nodes, which is like Cubelet, Proxy, and so outside of the whole cluster, we have kubectl and tool to interact with your cluster, right? And so now let's discuss about etcd. So etcd is nothing, as I mentioned, it's a key value store, which will have all the data and all the details about your cluster, your node details, what goes in, what goes out, all sort of information. And if etcd is deleted, your cluster is gone, kind of a thing, right? So you need to consider, so if you're considering like your master node with at most security, then you also need to consider etcd is also like very similar to that. You need to consider etcd its core component or key component of your cluster. If etcd is, and your entire cluster is exposed, right? So if you alter some values in etcd, it will directly reflect in your cluster. Or if it is deleted, you will lose your cluster. Okay. And controller, let's say, so there are like multiple controllers, as I mentioned, like for example, job controller, service account controller, controller, and so on. And so basically, this controller controls the object of the Kubernetes. And we have kube scheduler. So basically, this particular scheduler, it's meant for scheduling the application or scheduling a pod on a specific node. You do kubectl run from your CLI, and you are asking server to launch a new pod on node 2, for example. Okay, it will not immediately do that. So the kube scheduler will get the information from etcd, and then it will see whether there is an availability or not based on the resource or whatever, and then the scheduler will schedule it. So all the information will be the trigger will be from kubectl, but then the kube scheduler, but then the input for kube scheduler will be from okay. So kube API server is the entry point from outside. So this is one of the key components, and all this connections, let's say etcd to kube scheduler or everything it's like secure using TLS certificates. So when you actually do an installation session, or else if you try to create your Kubernetes cluster from scratch, go through all this process, all the in each components are like highly secured, and it has a TLS certificate enabled. Okay, and so if you so that is for the installation, right? So let's say consider if you're trying to create a cluster on cloud, then all these components will be covered as part of your cloud provider, and you will be full access to control your nodes. Cubelet. So Cubelet is the one. Okay. I mean, I'm just trying to get an example from nodes, right? So he mentioned Cubelet will be an ship highlight for that specific node. So consider this as the master component, or it's the head of this node. Okay, all the communication to the node will come via Cubelet. Okay, so as I mentioned just some time back, if you don't have your master is gone for some XY Z reason, or else you are bringing your master down, and all of a sudden there is an application team, they want to schedule a specific application on node 1, you can still do it by getting the reference of Cubelet. Cubelet has its own path, and Cubelet is not installed as part of your cluster components. Cubelet is still installed as a separate component. Cubelet and kubectl is installed as a separate component, which we will see. And kubeproxy. So kubeproxy is the one which doesn't what is it? So this is the one which allows the network into your pod. So basically, this is kind of a bridge between outside world for your pod. So all your communications to the network will be passed through kubeproxy. And of course, we need an runtime engine. So in our case, we're going to discuss about Docker, and even for your exam, Docker is good enough. And trust me, you will not be asked any questions around Docker, but you can also try with a lot of other runtime engines, for example, Rocket or something else as well. But in my lab, I'm going to show like with Docker, right? And this is what it is. It's pretty simple, and these are the components. And kubectl, like Cubelet, it's a separate binary, so it will be it can be installed on your local. And so when you create a cluster, there will be an consider you will get a username and password which is called context based on your cluster name, and you can import the context, and then from your kubectl you can make an API call to your API server, so that like you can do everything from your workstation. That's what it is. And I'm just going to show you, like, in case if you guys have one cluster already, it's good. If you don't have one, or else if you don't have a platform to create one, then the stuff which I'm going to show you now will definitely help you. Yeah. And we're going to share all the links and the code which we are using for this specific lab in the chat, or else after this session, or else we will also send it across. And yeah, there is the one. This lab using Docker, Vagrant, and the Kubernetes. It's very pretty simple, and you will have your full 3-node cluster, which is like 1 master and 2 node up and running in like within yeah. So I already have it running, but then I will ensure that I will delete and recreate it once again. Okay. So can you guys still see my screen?
Yeah, we can see your. Yeah, now we can see your ID.
Okay.
Can you please make the font a little bit bigger if you can?
Yeah, sure. I can do that. Okay, let me know if it is okay.
That's much better. Yeah.
Delete. So in the meantime, I have explained everything in the README file. So what are the components you need upfront, or else like the prerequisite, a specific setup to run. Thing in the README file, you just need to follow those README file, and then you should be having 1 master and 2 worker nodes for your lab. Yes, if you want to delete it, you can use Vagrant destroy, or else if you want to forcefully delete it, FNF, or else if you want to just shut down it, and then if you want to resume it again, then you can just do like halt. And yeah, it's done. And I'm just gonna spin up a new cluster now. So let's say before that, I will ensure that I cannot log into anything. So Vagrant SSH. Okay, it's saying like, okay, I need to create an machine, right? So I don't have anything running. So now, which you need to run, everything it's like pre-configured. You need not to do anything. Just run it and sit and relax for 2-3 minutes. End of this, you will have fully functioning cluster. And if you want to modify anything, you can actually write a pull request, or else you can fork it and then make the changes in your own repo. So because I made the repos public, and in the meantime, I can tell you like this one will install Cube Atom. So all the latest version of Cube components will be installed. For example, the components which we have discussed over here, etcd, everything. So all the latest components will be installed along with this kubectl, so on. And then I'm also including the, what is this? Yep. So basically, I'm using Kubelet free to use anything you want. You can use Calico for your as a network plugin. You can do like a lot of things with Calico, or else you can also do like a lot of other things. But I have you chosen this because it's kind of very easy, straightforward, flat, and but it will not restrict you. You can still one tooling for this, and the place to change it, it's a master init.sh. You just need to change, comment it, and then change it according to your wish. You are also, in case if there is any customization needs to be done on top of it, just ensure that like you're doing it accordingly. But this one works perfectly fine. I can show you in a minute, and I'm also doing like kubectl completion bash. This will help me to autocomplete the when I run it, right? And if you see, it is installed, and now it's the master is ready, and you can also see like okay, I network plugins, and then yeah, added all the configurations. It also giving me a cube Adam join. So this is the command which I will be using uh, to add my nodes with my master, and is being initialized. Yeah, so in the meantime, if anyone wants to cover anything or is add some extra topics or points, please feel free to do that
Prem,
because this will definitely take.
Prem, can I show the installation on the nodes that I have
Yeah.
the setup? Okay. Yeah. Hi everyone. So while Prem is doing his stuff, I will present my screen, and I will show the installation, how it is to be done. So installation is one of the important parts of your exam. So you'll be given probably a must node, and I mean not a must node. You'll be given a machine, and then you have to install Kubernetes setup there. Okay. Prems, do you have to stop the sharing, or I can share my screen?
Mitlesh, I think you can just go ahead and share your screen, and it will take over the control.
Okay. Okay. I hope everyone is able to see it.
Yeah, we see your code cloud environment.
Yeah, so this I have already started the environment. So we have one machine here, which is called control plane. So this is just a normal Ubuntu machine where there is Kubernetes is not installed at the moment. So this is from the course. This is a Mumshad course from Udemy. It is a very popular course on CKA. So I just use their environment to show how it is going to be when you install Kubernetes on the machine. So we go to this quiz. Okay. So first thing we're gonna do, as Prem has already mentioned, that you have a master node, which is the management control plane, which takes care of all the management stuff, and then you have various worker nodes for scheduling your pods. Okay, so there will be you can have one or more master nodes, and then various worker nodes also scheduling. And on the master node, you need to have all the management components. So you have this API server, you have the etcd, you have the the scheduler, all the and the controller manager. So all this stuff will be there on the master node, and then worker nodes you will have several other components that needs to be installed. So what we'll do is okay, I think Is my tabs visible?
Yeah, that's a good question. We see right now the terminal tab.
Okay. All right. So I think I need to share my whole screen then.
Yeah, let's try to share the whole screen.
Yeah. So you can see now?
Yeah, we can see your install the CubeAdmin tab.
Yeah. So there are two types of installation methods. Either you can do the hard way, where you install all the components one by one and then do all the setups and configuration. But as part of the exam, you will not be asked to do that. So you will be using CubeADM tool, and using CubeADM tool will be doing all the installation. So that is what I'm going to cover here. So first thing is we'll install CubeADM package. So we have one node, which is a master node, and there is one worker node, which is called node 01. So first thing is we are going to install it. So if I go to hint, you see that it is pointing to the Kubernetes documentation. So this is very important for as part of your exam. So you can see the documentation in your exam. So it is very good point that any thing important, you can just bookmark it so that you can refer it during your exam quickly. So if you have to refer this one, you can just quickly bookmark it, and then you can make a bookmark folder, and all the important bookmarks you can bookmark so that you can easily refer it in the exam. So this is a Debian-based Ubuntu distribution. So I will use this to do my installation. So I'll just copy and paste the commands here. So this is on the master node. So this I'm installing stuff there. So if you are aware of any of the Linux Debian-based distribution, you will already be aware of this installation steps that you have to install the softwares. Okay, done. We have the repository. And then we install the component. So what we are going to install is Cubelet, CubeADM, and kubectl. Cubelet is the agent which is running all the nodes. Then you have CubeADM, which is the admin tool for installation, and that kubectl, which you'll be using to access your API server and to use all the commands from Kubernetes. So it is like when you have Docker, you use Docker to do anything. So you use Docker run, you use Docker RM, you use Docker images. So similarly, you have kubectl command for Kubernetes, which you'll be using. So we are going to install all this here.
Meanwhile, let me just ask a quick question. Here's a question in the chat. What are your operating configs to start with to start this process? Then how about Windows? What's operating system we normally get in exam?
Yeah.
So basically, in exam you will get Ubuntu.
Ubuntu. Okay.
It's Ubuntu.
So this is what I'm showing.
Nice, nice. So yeah, Ubuntu is very much available to everyone. It's a free operating system. You can download the image. You can install it on any, even old computer to play around, you know, also as a virtual machine. So it's a great choice, I think.
So the script which I have shown before, So that is built on top of Ubuntu. So Debian. So basically, like it's all open source. If you guys can do some hands-on with that, then you should be good.
Yeah. The Ubuntu and Debian
Okay.
are compatible, and I think it built on top of Debian, anyways.
Yeah.
So we have installed this on one of the machines. We go to the we do SSH to the next machine, and then we install it there as well.
Yeah, can we also install in Windows?
Windows, I don't think so. I mean, you cannot directly install Windows. Prem, you can correct if I'm wrong. But when I have done, you can use WSL, which is the Windows system for Linux, and then you can install a Ubuntu machine again there. So it is again the same thing. Like you will be directly working on the Linux system.
That's correct.
Yes, correct. And you can use other operating system like Arduino also, Arduino, Linux, CentOS, Fedora, whatever you want. That Linux will
Yes.
open.
So it's all Unix systems that is required.
Yes.
Okay, so we have installed this on both the nodes, both the machines. Okay.
And if you see here, right, so there are like three components which is ideally getting installed. One is Cubelet, kubectl, and CubeAtom. So that is what it's needed. And if you just go back to the diagram explanation which I mentioned, so I said like Cubelet and kubectl will be installed as a separate component, wherein the etcd and Cube API, Cube Scheduler, everything is a single component as part of CubeAtom. When you install CubeAtom, you will get as a whole bunch, but that one doesn't limit you, so you can still install etcd as a separate component for yourself. So let's say you're going to have some sort of a production setup, and you're gonna do the installation from scratch. You can ensure that like your etcd is highly available, and you can install etcd by yourself. So you can do a separate installation, and maybe we can also see that in the configuration file where you need to change the endpoints.
Okay, so shall I move on?
Yeah.
So now we have installed CubeADM, which is the tool that will be interacting for installation. Okay, now we want to run some commands. So we run kubectl get nodes to see what I have in my Kubernetes environment. So it says server doesn't have a resource type. Okay. So this is what it comes now. So it says it does not have a resource type because we have not initialized it. We just have installed it, but we have not initialized it, and we have not made which one is going to be the master node. So we have two nodes here, and one of them we are going to make it the master node so that our Kubernetes environment is ready. Okay. So for that, we do kubeadm init. So we are initializing this, and this control plane, which is the name of the machine, we are making it as the master node. So this is something similar you will find in your exam as well. So you'll be given, you'll be asked to install in one of the machines that will be mentioned there. Okay, now to start working, it already gives you the instructions when you run this. So as a regular user, you have to do this step. So you have to create a .cube directory, and then you have to copy this configuration file into your local directory, and then you have to own that directory. for that local user which is running this. So we'll run this, and there is a command which is also important. So we'll copy all this and then we'll keep it so that we can use it. So we run these three commands. So this is just to make sure that you can run it from your home directory rather than calling your configuration file from etc Kubernetes every time. You can just run things from your home directory. Okay, so this is done. If you see, it's not there yet. Sorry, it was already done. Yeah, it was. It is as a hidden folder, so it is done. You have a .cube, and inside .cube you have the configuration file which is copied. Okay, so it says that set up the environment file, environment config file, and then wait for the node to be part of the cluster. Okay, so we have already done that. We have already copied the configuration file. Next step is it now. If we run that command again, which we are running before, now you see that you have one node. So one node is ready in the Kubernetes environment. One node is there, but it is not yet ready. So we need now what we have to do is we need to join this another node also to the cluster. So how do we do that? We have this command. Okay, before that, you have to run one of the, so it is saying not ready. So not ready because it is not configured yet. So you don't have a network communication yet. So we'll do that. So
Added to that, just from exam point of view, because in the chat I'm seeing like a lot of questions around exams, like how it will be. So you will not get a question to introduce or like to join a new node into your cluster. So trust me, I mean, at least I never faced that question in my exam. And so, but then you will be tested on troubleshooting the issues with the nodes. For example, that might, so now right now if you see right, the control plane which is master, it's not ready. So you will have one question like, okay, the master is not ready, try to identify the issue and rectify it so that it will come up again. So you will have questions like this, and as part of our troubleshooting I can give you some examples as we go through, but you need to be aware that this is only needed for the knowledge, not for the exam. So, but then it is good to know because when you create your own cluster, you need to know like how the nodes and masters are getting, speaking to each other. And in case if you lose this token, and you also need to know like how you can regenerate that token, how to reprint that token so that you will get a new token, or else how you can create a new token asset. So all this sort of scenarios you can practice it by yourself by creating your own setup, but then for exam you will be getting any of those.
yeah, so we'll see that. I think we can take this as one of the troubleshooting frame why the node is not ready. Yeah,
Yeah.
so what I'm going to do is I'm going to run this command to join the node to the cluster. So I've done SSH to this node, and I'm running that command. And now it says that this node has joined the cluster. So I go back and I run the same command again, and now we see that both are not ready. So if they are not ready, then we are not ready, which means we are not able to deploy any pods or do anything on this cluster. Our cluster is there, but it is not in ready state to accept any workloads. So let us see. We have done that. Now it says that install a network plugin. So this is what we have to do to get the environment ready so that we are able to get the get it in ready state. So now you see that if you are given a troubleshooting question why it is not ready, then you see that this probably this network thing is not yet installed, and that is why it is not in ready state.
No, another thing you need to check if it is not ready state. Sometimes is network is running, CNI is there, but problem is this question you guys will get kind of thing. You need to check that service for Cubelet. Cubelet is responsible for means everything. So if that Cubelet service is down, so that it will show that not ready state. So basically you need to start that service, you need to enable the service, and then you need to check in from that master, you can get it that is node is your ready state.
Okay. That is for the nodes, not for the masters, because in masters you will not have kubelets. And so, of course, the networking profile can be one of the key things needed actually to have the communication between your masters and the nodes, and yeah, there can be also a lot of other scenarios. For example, you are doing it with CubeAtom, right? So the CubeAtom uses manifest file, which is like again a pod all the individual components like etcd and the scheduler, so on. So there could be also one scenario or case services may have some issues, and you need to know like what is the and before doing that, before assuming that this particular cluster is provisioned or installed on CubeAtom, just try to check whether it is actually installed on Atom or CubeADM or with a binary. So that is actually important thing. Yeah, because if you install as a binary, all the components will be installed as a separate thing, and you are using Linux flavor, and it will be installed as a separate service. So you need to do with systemctl service, or else you need to find the package whether the package is installed or not, so on, right? So if you find out that okay, this is installed with binary, the set of procedures is way far different from the one which which Mithilesh is showing now, right? So just try to understand the logic behind it. When you actually appear for CKA, you need to know the root path for each and every component. Okay, so if it is CubeAtom, the config file will be lying. So what is the file for the manifest path for the manifest files and so on. So important.
Okay, so this is Prem. This CNI, the network plugin, right? Do you have idea where is that command I can look to?
Yeah, I mean, just go to or else from CubeAtom, right? So which network plugin or profile you are trying to install?
So if I go here,
Name of the network profiler, I can just get you the link. Okay.
we've
Okay. On your chat now. There you go. Yeah, so as I mentioned before, there are like multiple network profiler, and I have used different one in my lab setup, which is like very flat. You can use it. It works. I will show you like one Measures lab because my provisioning is almost it's literally done. And this is like a different plugin. And if you see the name of the plugin right here, you can actually see. So this one is different than the one which I have used is different. And in the real exam, you will be allowed to use one more extra tab where you can actually go through Kubernetes.io docs and GitHub Kubernetes page and one more page to enter into discussion or discussion.kubernetes page or to the outside page. For example, go back to the terminal.
Okay.
So if you see here, right, this particular it's coming from a different cloud.wave.works, and in exam you will not be allowed to route to this particular website. Okay, but what you can do, right? You can actually bookmark these pages from Kubernetes.io because Kubernetes.io have all the reference for installing this specific plugin. You can find that page and create a bookmark of it so that in the exam it will be very handy. So when you have this sort of an task, you can directly go to the plugin and then copy and paste and run this.
Yeah, so this is also even in my exam I was struggling because I did not bookmark the proper pages, so that was creating a lot of issues. So if you can see how I was trying to search now, that same thing I was trying to do there. So it is very important that you, whatever you are doing from the documentation, you bookmark it properly under a proper folder so that it is easy to find out exactly where you have put the information in. So now you can see that we have done this network thing as well. So if I say again, get nodes. So you can see that both the nodes are now ready, which means both are ready to take the workloads. And we have our cluster now ready, so we can install anything in our cluster.
And did you guys find a difference in there? And if you see the version of the master and the node, the versions are different. In theory, in the exams, it will not be like that. Everything will be on the same version. If this is the case, you will have like a lot of issues because you will be given a task to maybe you may get, you may not get. At least I got in my exam, so to upgrade my cluster, and for upgrading the cluster, you can actually refer the official document. You cannot upgrade to one different version. For example, you cannot go from 1.90 to 1.21. That is not possible. You can go to the next higher version, but not to the second higher version, something like that. So there is a document. Yeah, thanks for opening it.
Yeah, I think it's there.
So on the top, exactly. So you can go to like next minor version, not to the actual major version, and you can read about it. And this is important. And tried to do this for 5 minutes. Even though I know it, I just missed I-100, which literally pissed me off for certain sometime in the exam. And for a second, I thought like, okay, let me flag this question and then come back at the end. Then I realized what I'm doing wrong, So then I corrected myself and then did the upgrade. Okay.
Yeah. So this installation is done, and our this is in ready state. So if you see, check now, it is done, and the installation is completed. So over to you, Prem.
Yeah. Okay. So I'm just gonna share my screen now. let's go back to my lab setup. Okay, so screen now, right? My
Yes.
lab.
Yeah, we can
Font is
see your
big enough.
screen.
Okay. So as I said, I just ran that script and nothing much I did. You can actually see, and then I just tried going through in my script. I logged into all the nodes to ensure that like okay, it is actually working or not. Everything works, and now just gonna get into my master. Oh shit. Okay. And so in my case, once again, I'm just showing you because Mithilesh has already shown in real practical thing. If I go here, I'm not using Wave network plugin. I'm using and Docker as my base container, and I'm also installing Cubelet and Kubernetes and kubectl as a separate package. Right, so this is what is important, and I'm using CubeAtom. So I'm not doing the Kubernetes cluster installation using binary. If you want to do so, free to do so. Only thing it's like, right, you need to make your changes to your base.sh script. And now we're just going to check whether all our parts are running or not. I mean, all our nodes are running or not, right? I have one master, two nodes, and everything is running state. And if you see the version, right, this is the latest version. Okay. And so basically, from the exam point of view, so as I explained as part of my installation, I did an autocomplete script. I added an autocomplete script, so I can show you like how press cube and then giving like tab. It's giving me option like what I need to choose, right? So kubectl. Let's say I want to get pods, right? So if I just give like, it's giving me the additional option. So this is really handy when you actually struggle with some commands in the exam. But there is also one more thing. You can actually create alias like this. For example, ATL, and you can still do this, okay? Because there is no pod running on my default namespace, and I will show you. I will tell you why. But if you see here, right, you can create alias. And if I'm not wrong, for CKAD exam, I did do this. I created a lot of alias. I did spend some time. But when I was working on CKA exam, I actually really didn't bother about creating alias because I was very much comfortable using the full command like kubectl because I was way faster than using creating this alias for each and every. Do this auto completion for both of my exams, and this you can do. It's allowed in case if you guys don't know what else we can do. Okay, so now, since as I explained before, when you do like cube add-on, all the core components will be installed as a part, right? So it will not be running as a separate package. Like for example, cube, let's say system CTL status cube add-on. Okay, it's not installed as a service. Fine. Okay, so if you see here, right, Cubelet, it's a separate service and it's running as an it's a separate package and it's running as a service on my Ubuntu box, right? etcd not a command. I mean, because it's not running as an service, but I still have my etcd, right? And that is over here. And if you see here, this is the default path for the manifest file, and this one we will be discussing as part of workloads and scheduling topic. But if you see here, right, this is the default path, and this is the place where you will see all the components manifest file. Okay, and as we discussed, when your node is not ready, or else when your master is not ready, there could be high chance some file might be missing here, or else there might be issue with uh, some content in this file. For example, in etcd be different, and you need to change it, or else for cube scheduler, the image which it is referred, the image name might be like to correct the image name, and that could also cause your your pod or your cluster not to run. So it's not always that network plugin issue. It can be also a lot of different issues, and you need to be aware of it. And yeah. And now let's go back to the pod. So pod is the small unit in the Kubernetes cluster. It's an runtime unit. That pod is an uh, separate VM, and each pod has its own IP. And inside a pod, since I mentioned pod as a VM, you can run multiple applications, right? In the same way, in a pod, you can run multiple applications, which is good. You can still do it. You need not to have like multiple pods, but Kubernetes official document doesn't encourage that, right? If you have some sort of an sidecar container which needs to run, for example, you have your application and the application produces a lot of logs, and the log needs to be collected. You need to have a collector as part of your application. Then that you can run as an run as a sidecar container, right? So you can run in the same pod. If you think to have highly scalable solution, then it's always best approach to run your application in two different pods, not on same pod. And even when we do work on replicas, you can actually see that it will be like running in two pods, not on the same pod, unless until you explicitly define it. Okay. And what else I can? So there is one more concept called init containers. So init containers is the is the one which will be like initialized at the first. Let's say, for example, you want to run an application, and the application has some dependency from X and Y URL, right? So you can add that init container, that particular declaration as part of your init container, and your init container will run first, and your actual container will wait until your init container is executed, right? What init container is. Let's say, for example, right now, don't have any parts running space, right? So let's see, like, okay, get namespace. So I have like 4 namespace. So this is the default namespace. Let's say the namespaces are nothing but virtual groups. Okay, it's just a virtual box which is used to bundle all your applications specific to one specific project, and you can implement RBAC and the policies, net polls, everything based on namespace as well, right? So that will have more control. And in case if you want to just destroy the whole application of a specific team or a project, and if they have a specific namespace, if you delete that namespace, all the applications contain spots, network layer, service account, whatever it is, you just name it, so inside that particular cluster will be gone. And what else? All the key components we have all the key components whichever we are using, whichever we have installed, it will be there as part of Cube system. Okay, so let me show that. kubectl get pods -m Cube system, right? So if you see here, my core DNS, etcd, API server, controller, and my network plugins, my network ports, a proxy, scheduler, everything is running in my Cube system. So in case if I just delete my Cube system, the things are gone, right? But it won't. Again, it will ensure that my cluster is up and running. And that's the beauty of manifest file, because manifest file in the configuration of Kubernetes, the manifest path will is set as an uh, static file pod path, right? So what is meant by static pod path? So static part is nothing but just add an manifest file into that static the kubelet which is running on that specific server will ensure to bring that specific declaration into one part by default. So you need not to schedule anything. Your kube scheduler is not needed. It will come up automatically just because your kube configuration file says that path for pod path for this specific cluster. I also come up and say that is your extra. Okay, my
Yeah,
I
Prem,
have been kicked out from my.
I just wanted to add one thing here, that here that static pod is not maintained by that Cube API server, or maybe I can say control plane. So this Cube static pod is maintained by Cubelet service, whichever we have, which is, or I can say that Cubelet daemon, which is running in all that node. So static pod is basically maintained by that Cubelet only.
Correct. Okay, something happened with my. Okay, nevertheless, I just want to cover one specific topic. That's totally fine. So you can actually make use of this specific to spin up your own cluster in case if you don't want to have given if you want to just have some sort of a virtual environment created on online, you can always use you can always refer this website. And something got crashed. This always happens when we shitty. Okay, I need 3 more minutes. This website is busy now. Madras, do you have your platform up and running? Any chance?
The not the platform, that the this lab is there, but there are specific labs. So
No. That's fine. Just go there. Because I don't want to wait.
what do you want me to do, Prem? Sorry.
Just create a.
Okay.
Just create a Nginx Spark, and that's it.
Okay.
And I'm giving the command in the chat already. Okay. And yeah, just create it in the default namespace as it is.
I'll just go to this play with Kubernetes and do it. Yeah.
Yeah, but then it will take like some time to spin up your cluster.
Yeah. Then I will log into one of these machines quickly in my lab.
Okay.
Yeah. Just a second. Yeah, but this will also take some time provisioning a lab environment.
Let me share my screen. I have that cluster ready.
Okay, cool.
Yeah. just let me know.
Yeah, we can see your screen.
Yeah, that nginx is running. Yeah.
If you want, you can try to increase your font a little bit, so that makes letters bigger.
Sure.
That looks really much better. Thank you so much.
Yeah, Prem, are you there?
Oh, I fear we lost Prem for a second, but he will probably return just in a moment. Meanwhile, yeah, we're also watching the stream conversation. Dear speakers, is there anything you have spotted? What can be discussed? Oh, Lucas is joining also in the chat. What is nice, our member. Anything you want to discuss? Meanwhile, we can, or if you have specific questions to the session or Kubernetes in general, feel free to post them into the chat, stream chat, and we will address them.
Yeah, there is a question I can see that Harish Sharma asked one question that a instance from where you can run your kubectl command. Yes, we can able to run kubectl command. Just you install, just create one of your EC2 instance or maybe whatever your jump server you can call. You just install that kubectl command utility. The same way we need, means it is there in that Kubernetes IO. You need to install that kubectl, and that you have that access between your jump server to your cluster. Then only you can able to see, you can run anything with that kubectl command, and you can get that output from your cluster.
I think there is another question from Amandeep. So he wanted to know, for a DevOps engineer, does someone really needs to have this low-level knowledge and very deep about the Kubernetes architecture and all this stuff that we are discussing? So if Titu or Prem can answer, that would be good.
Sorry, Mithilesh, what he is asking?
Do we need all these details from a DevOps engineer perspective? I mean, does he need to know?
Yes, if you working in means Kubernetes environment, so you need to understand, though you are not a Kubernetes administrator, no means, but you need to know about that, what is that Kubernetes utility, what is this component, and how to use how to use that kubectl command line utility to deploy your pods or maybe deployment, any kind of thing, or you can your microservice. So it is little bit knowledge it is required for means using Kubernetes environment. Maybe you are using that AWS EKS, maybe you are using Azure Kubernetes service, or maybe GKA you are using. So for each and every service, whatever your environment you are using, but Kubernetes little bit knowledge is required, and that core component is required to know.
And speaking generally, I think Kubernetes is a very important part of a DevOps role anyways.
Yes.
So even if you are using one of the solutions, like we are deploying things and OpenShift, so if you already have knowledge on Kubernetes, then it helps a lot, because this is again wrapping Red Hat and Linux stuff around Kubernetes. So if you have knowledge, then it will be easy to understand how things are working, because then you can have look at whatever, whether you're using Google Kubernetes engine or you're using Azure Kubernetes service, all are under the hoods. They're using Kubernetes as their main tool.
Welcome back, Prem. Please unmute yourself.
Sorry, I lost connection for a minute. Okay,
No worries. No
where
worries.
were we? Who's
Yeah.
doing what?
Yeah, Tito is showing the screen now, sharing the screen, and he has an environment. He executed kubectl run
Okay,
nginx.
okay, so nice. And if you see here, right, from the previous line, he has just ran the command kubectl run image equal to nginx, and he really didn't define okay on which specific resource group, or it's not resource group, it's AWS, I mean Azure terms, right? To which namespace this has to go, right? And when you're not specifying a namespace, yeah, explicitly, then all the pods, all the services, whatever it is which you are creating, it will just go to one default namespace. And in order to see that, now let's do one more thing, right? So kubectl get namespace. Yes, yeah. If you see here, so you have specific namespace, or else get pod -ns. Maybe it would be nice. I have my screen. Can I take over,
Yeah,
Tito?
sure. Before proceeding, just Prem, just one second. There is a
Yeah.
question from Harsh. Harsh, actually, if you see my screen, I have deployed my Kubernetes cluster in my own virtual workstation. There is a only master and worker is there, which I powered on. So one master, two worker node is there. So you can able to do minimum 2 GB, 2 GB RAM, 2 CPU, and just 20 GB to 30 GB HDD is required for that one. That is enough for your
Mhm.
instance in your cluster. Over to you, Pem.
I think I think the Kubernetes, the easy way script will create you one same sort of a similar cluster with very less configuration things. If you want to refer, right, we have already shared the link in the chat. You can actually go through that, and which will give you a full brand new components installed in it. Okay. I'm going to quickly share my screen and complete the power design stuff because we are discussing about it for a long time now. Let's go back to my lab, and yeah, so luckily it's still up and running. And pods, so there is no pods, and what I'm going to do, I'm still going to run the same command, kubectl run pod. Yes, Amish, you guys can see my screen, right?
We could before. Now you switch to Google meeting. Yeah, now we can see
Okay.
again.
Okay.
If you could make a little bit the font a little bit bigger, it will be like amazing. Way better. Thank you so much.
Okay. Nginx pod from the Nginx emails, right? And so the pod is created, and the way to check this, kubectl get io. And see, every time when you actually do this, without specifying a specific namespace, just show you the details from the default namespace. The way to change it, it's like, right, when you try to set up your context, you can actually specify on what namespace your context needs to open. For example, kind of a root folder thing, right? So in a layman way. So you can specify what is your key namespace. So here right now by default it's default, but you can change it. Let's say you can, if your name is A, you can create a namespace A, and you can ensure that every time when you do like kubectl get pod without specifying a namespace, it will come from that specific namespace called A. So that is possible. And so how it is deployed on namespace, right? So if you see here, I'm listing everything, but then that's fine. If you see here, right, the Nginx part, it's installed on default namespace. It was not installed on anything else. The same example, what I'm going to do, I'm going to create a new namespace called dot. Okay, sorry. Okay, now if I do like kubectl get namespace, you can see a namespace called frame, and in one server, uh, this is one single system, right? So what I'm going to do, I'm still going to run the same nginx part command, but I'm still going to specify the namespace explicitly, and this time pod hyphen namespace called frame, and I still have my one more nginx part got scheduled on different namespace called frame, and if I use this command, you can also see like one nginx running in frame namespace and another one is running on namespace, right? And what is our next topic? So with this, what borders, and it's a small unit, right? And now, so uh, consider, I see basically like this particular pod is volatile. So all the information which you put inside that pod, it will be there and till the pod is deleted, you will lose all your data, right? For example, you run your database in an pod, and you want to save the data. If you don't have any sort of an persistent volume attached to it, what will happen, right? By the time when the pod is terminated, you will lose your data, and that's where persistent volume clients comes into picture. So basically, the volumes comes into picture. And what is persistent volume? So you have some sort of a physical volume, and you want to map this virtual volume to the physical volume, and that's why you are actually using persistent volume. It just binds between your core volume, which is like physical volume, with your virtual volume. And what is this persistent volume client? Okay, you have a bundle that includes something, but how you can actually take piece of it, right? So you can have one persistent volume, multiple pods, multiple containers. You can climb it as much as you want, but then how you will actually climb it, and that's where persistent volume client comes into picture. So you have one volume which is bind at some piece of cake, and you want one specific piece for your part, and that's where persistent volume client comes into picture, and the persistent volume client can be mounted into your part, and that's where volume mounts comes into picture. So when you do this, it's saved. Even if your container is deleted, because of this, your volume will be still saved. And Mithilus, do you want to show the lab of this, or can I do it myself?
I think you can do if you have, but I just wanted to add a little bit an example which I had understood for PV and PVC. Can I go ahead?
Please.
Yeah, so this is a funny example of how I understood. So you see, if you are, for example, if you're going to a hotel, right? So you are going to a hotel, and when you're going to hotel, you have to book a room to stay. So when you book a room, the rooms, right? The rooms are already available. It is not that when you're going to book a hotel, they will create the room for you. The room is already available, but you have to utilize that room, right? So the rooms are the PV, which is the persistent volumes, and what you request, like you want a particular room, that is the PVC, which is persistent volume claim. So you make a claim to that room, and when you make a claim to that room, you cannot directly enter the room. So you go via, say, a helper or a receptionist, and that person helps you. So that is what is storage class. So that helps you book that room. So that is how I have understood about PV and PVC.
And it is basically one-to-one mapping, means like you have 10 GB PV, and that PVC you are claiming for a particular port for 8 GB, that 2 GB is wasted, so you cannot assign that 2 GB to some other pod also. So it is one-to-one claiming.
Yeah, so it is like you when you enter the room, that room is yours, so you cannot share that with others.
Yeah, that is the reason.
So for CKA, you will get like kind of a very small scenario, like okay, create a persistent volume and do the persistent volume client and mount it to a specific part and so on. Wherein in CKA, you will be asked to dynamically size of your volume, right? So let's say they may ask you to go up, down, and without editing anything on your existing pod, because once you mount it to the pod, your pod needs to run. But then they will be also one question like, okay, your pod is running, you should not disturb that, but then you still have to make changes to your volume and you need to increase your volume, and you will have this scenario, something like that. And yeah, I just took this snippet from the official website, and what it does, right? It just consumes a certain amount of storage from my host path, which is my base virtual machine, and then it creates a class name called manual. And so this class storage class name and access mode is very much important. This access mode and the storage class name, you will be actually declaring it in your persistent volume client. uh, Creates a bind between these two things, right? And that's what we're gonna do. So I am gonna create now, and always try to practice heavily with imperative commands. Don't always lie on creating the file, because in exam you really won't have time to do that, right? So the more you practice with the CLI, the faster it gets when you actually sit in the exam. Okay, and so my PV is created, and since I haven't specified any namespace, uh, I haven't created specified any namespace. So get PV, it will come from the default. And if you see here, right, and so the status is available because this is still available. It was not claimed by any persistent any PVCs, and you can also see here, no claim. There's things, and you can see the details. And for example, questions in CKA where you will be just asked to create PVC and mount it to one specific pod, wherein you need not to create the PV. You will not be asked to create a persistent volume. So you need to actually check what are these values, and based on this value only, you will be able to create your persistent volume planner, right? So now let's create PVC, okay? And again, I'm gonna take some reference from the, okay, let's take this one. Okay. I think I referred, how much is that? 1 MB, right? I'm planning the full thing because anyhow, it's just an example. And if you see here, I'm specifying my storage class name, manual, and my access mode as rewrite once, the same way I did it in the previous persistent volume declaration, right? So now, what I'm going to do, I'm going to do this. And if you see here, right, it gives my persistent volume client name, and it says like it is bounded. And if you see the status over here, before it is available, and now the status, everything has been changed. PVC. And now, if you see here, right, this is done. So with this way, you can actually create a persistent volume, and you can also create a persistent volume climb. Now we will see how you can mount this into one part, because that is important, right? That's why we are creating all these labs. Let's go over here and let's create a PV part. PV star.yaml. Okay, and okay, so since I haven't changed any name, I'm going to leave it as it is. And if you see here, right, the volume declarations and the container declaration should be on the same line. And this is very much important because this can cost you a lot of time during the exam. If you're not good enough with YAML format, just try to practice it, because this is really needed from the exam point of view. Yeah, and yeah, so here I'm using my persistent volume name, and I'm giving a specific name to this particular volume, and I'm referring that volume over here, the volume name, task PV storage, and you can give any mount point based upon your need. So, but I'm not going to do that. And if I run this here, it will definitely throw me an error, because why? Because here I'm not specifying any namespace name, and I already running Nginx part in that default namespace. So it will have some issues. But what I'm going to do is delete delete Nginx. Nginx. This is important command which will ensure that so when you add this particular command, right, so your part will be deleted gracefully and fastly. Else, what will happen, right? You have to wait for a long time to delete to get your part deleted, and you will not have that much time. And yeah, so in the exam, so just make use of this command to delete it fastly. Okay. And now what I'm going to do is I'm going to run this command. The part is created. Now if I just it is it is climbed, right? So the things are climbed, and it is there, and my part is still running. And in order to check the details, you have to do this. You just go there, kubectl, describe part, and if you go here, there will be a parameter called volume. See here, this is the name and persistent volume as referred in the namespace. It is created, read only files, and the things got created, right? And the mount points, you can actually see it here. It's creating a service account. You can ignore it now. We will come to this later. But if you see here, right, this is the path, right? So it is climbed from the volume which we have created. And with this way, you can actually and yeah, so it. And next, multi-container part, over to Tito.
Yeah, sure.
Yeah, we can see
Yeah,
your
hi,
screen now.
yeah. So, as we know that most of the time we are deploying pod, there is only one container we are mentioning. We are installing one container, or we can mention. Sometimes it is happened that we can install more than one container in a particular pod. So that use cases for multi-container pod means it is co-located and co-managed to help to use means one container to another. So sometimes for any kind of proxies, bridges, or adapter settings, we can use that multi-container pod. So I'm just showing you one example where that shared volume in means that Kubernetes multi-container will be used, or maybe just I'm going to install a simple example that installed only two container for a particular pod. Now, there is an example I have multi-container. If you see, I have created on YML file. I need to edit it. In your exam you will get kind of means question like you have three image and they are asking for you means install three container, or maybe 1 to 3 container, maybe 1 to 4 container pod using that three image. So what you need to do, you need to just create a YML file for a particular pod, and here once in that container section you just use that name image. Here for one container I use nginx, and another container I will use kind of maybe httpd or alpine, and you should give that name. Name should be maybe different, that alpine. To create, I use default namespace, so it should be installed in default namespace only. Yeah, it is container creating. If you see that I have two container creating and nothing is ready till now. Yeah, not ready state still. So if you want to check if there is crash loop back, any kind of things happening in your exam, so what you need to do, you need to just describe that particular pod and see that event log for that particular pod. I am describing that one, kubectl describe yo. Okay, something happened to my warning that backup restarting that failed container. Okay, so if I use multi-container instead of alpine, if I use httpd and this one nginx and this one is multi, I don't need level, I don't need a resource also. That's it.
So basically, what is meant by back off in the sense there could be some issues with the pods, and that's why back off. So basically, there will be an error, and because of that error, the pod is getting executed, right? A lot of scenarios like this, you have like crash loop, the status is not ready and back off and what else? Um,
Error message, unit error, some kind of things it will
yeah,
show.
Init Containers. Yeah, there are like a lot of such things. I mean, it's not so many, but then 5 to 6. Just try to understand like what all those, because when you actually work on observability, like when you implement readiness, uh, or when you do work with the liveness prop, those sort of knowledge will be actually helpful, right? And yeah, this will also help you to troubleshoot your parts and clusters because as we discussed before, we already discussed like, okay, the part can be failed because of kubelet, it can be also failed because of the one reason pod doesn't have a resource to deploy on that specific node, or else the pod might have tens. So basically, you don't have a toleration, your pod declaration don't have a toleration to install on that node. So there could be multiple scenarios, and this is also one of the things for the pod level or for the node level. But it's always good to understand this from the troubleshooting point of view.
Yeah. For me, it was showing terminated. So each
So
and every
basically, that is issue with your pod. Can you just open your pod declaration?
BI pod
Name
dimension
HTTP.
containers image.
Okay. What was the issue? Can you describe it?
Yeah, this one basically right backup restarting my second container is terminating each and every time after creating. This one is terminated.
What is get the logs maybe?
Yeah, kubectl logs yo multi.
And specify the pod name. Sorry, container name. Because you have multiple containers, so I can see and the container name.
See, that is called what is called the name alpine pod.
Hyphen P because it is already destroyed. So the previous log we need to take. So hyphen P.
Mm.
No, no, no. Yeah.
Okay. Mm. No, it is already terminated. That is the reason.
Yeah, you can still get it. Okay, but there are only one of hyphen C. But we have arguments it's allowed. Declaration once again. This is now.
Yeah, cat multi-container. This is my declaration, small declaration.
Yes. Okay, I'm running the same thing in my.
Hmm.
So VOE. Okay. Maybe I will share it myself. Okay.
Okay.
After. Just to wrap up. So because I just want to show you like how you can actually create what we can do. So I'm already running Jenkins, right? So let me. Okay. So I'm gonna create an part declaration file, imperative way, which is like kind of very fast. I need to write everything. So I'm just gonna use the same thing, nginx hyphen image equal to nginx again, and then so try run equal to client hyphen -o dot YAML, and then I'm transferring that to a file called multi dot YAML. Okay, and there we go. So now the part is not created, but then it helps me to create the file, so which is awesome. So I need not to do it anything manually. Now change the name of the part. Let's say I will put multi, and this can be like this, and oh, so let's say image equal to this box, which is kind of easy one, right? Always, and I'm gonna use name this box. Okay. So what I'm gonna do, it's like that. I'm gonna create two containers in one part declaration, and subsidiary from yes, and the part is created. Now, if I just start from my default, so if you can see, right, actually be, yeah, normally you will see like /1, but then if you see here, right, it's like creating two containers, and the container is in creating state. So now if I create, right, one is cache space because of that. Describe pod. Restarting the failed container. Okay, that is it. Restarted. Restarted 3 times. That should not happen. Maybe yes, it maybe something else. Okay, maybe the image name or something like that. That's not correct.
Ahmed from the chat is suggesting that container must be containers. Just a remark.
It's containers only. That's not an issue. The issue with okay, there is some termination law. Fine, I can get that. with my space storage or something like that, but then I will check that. Okay, now it should be fine. Okay, again it's gone back to the thing. It's trying to restart. There is no issue, but then it's just there's an backup restarting failed container issue, but then it started the container. Okay, that is basically USY.
The busy box
Okay,
is written
fine.
funny. Once busy box, once buys box, right? It's a
That's
typo,
not the
right?
problem.
Oh, okay.
Yeah. Okay, I cannot change certain parameters by using edit, but then I can still change the name of the image. And I'm just trying to find some default image. Okay, maybe I'll just use Stevia. So, okay. So this is what he has used. 1.28. I'm just trying to use a specific version. I know. Oh man. Okay, it's not on. I don't know any specific version of PC box. If not, we'll try with some different image this time, but then let's see. Okay, this time please.
Maybe another version.
I think so. I tried with this one, but then
Can you try 1.17.2?
or else let's do this. Maybe I'll just install. Yeah, right, or else even Ubuntu. That is.
BusyBox, some version has some issues. Some of the versions work properly.
Yeah, I know. Okay, if it is crashing, then it could be some space issue or something like that. I don't know. Yeah, I think we are actually doing the troubleshooting thing because pulled image.
Yeah, that's what I wanted to say. We can simultaneously cover the other part as well, the troubleshooting part.
Yeah, I know there could be also an issue like my space is not enough to have this many images running because I have very less storage allocated to this lab. Straight terminator. Docker pull it's downloading the Ubuntu. Recent completed and amount of operations. Different experiences. It's completed. Image created container box. Items should restart. Retried. Back off. Okay. There is something wrong with the split pulled and why? That's strange. It's not even showing and
Yes, I test my production environment also, but it's same thing. Strange behavior for me. I simply use that one Redis and one kind
no.
of
So with my thing, I can clearly sense that it is because my image is there is some issue with my image pool, and maybe what I can do is just to go through with this. Let
Maybe
me.
you can put a sleep there and see, will it help?
No. Sleep will not help, but then I can change the name of the. I can run two Nginx containers, maybe with a different name. That's still possible. Um, it, what? Right, so to what I can actually do is and I just need to list it now that it's running. It is because Nginx is light featured and then not the Ubuntu, whichever image which it's pretty heavy. Yeah, so the Ubuntu, obviously I don't have much storage, and the other one, BusyBox. BusyBox, the version is wrong. So basically, it had an issue in pulling the image. And right now, I'm running two containers. Two containers. Each container has Nginx running in it, and it has different name. If you see here, kubectl describe pod multipod, then we can actually see here. Okay, just leave it with this. This is smooth error because I just changed it and it's still giving it the same name, and that's fine. If you see here, the container name, so container ID Docker pool, Nginx is pulled, and then the Nginx is pulled. So basically, this is one container name and this is another container name. I can also run one more container with a different name, but then I need to know a proper version. And this is how you will run multiple containers. And yeah, so yeah, basically like backup is something to do with your image, And if you face this issue, you need not to panic. Just ensure that, like, okay, whether it's like correctly pulled or not. And if it is correctly pulled, then just check whether the image which you pulled is configured correctly or not. So it's basically like something to do with the image. And of course, since I don't have enough storage, Ubuntu didn't get completely pulled. And the other one, I was like trying to misuse the image version. And
Yeah, for
that's
me,
what it is.
also it is working when I change from HTTPD to Redis database. Maybe something issue. It's suddenly working and two pods is running.
Okay. So that's it. Like, if there is any questions on the chat, I would like to see. If not,
Yeah, before proceeding, before closing, just if we give a small introduction regarding deployment, because in CKA exam, almost 4 to 5 questions will come from deployment. So it is good
I
to.
think we already have another session planned, right? So
Okay, so
we can follow up from there on the
okay,
equipment, I guess.
Yeah,
Karan, when it is?
correct. We have another session planned in 1 week. I just created it ad hoc as we saw that
Okay.
we have a lot of content to talk about and we don't have enough time for today.
Yes.
We already run for 2 hours and over the time. So we have another session. I shared the link in the stream. You can already go now and grab your seat for the next week. We will clear with the speakers what will be the exact time. I just set it the same time as today as default, but it might change, so watch the space. So we have about half of this content which we prepared for today still to be discussed, and we will shift it to the next session next week.
Yeah, that service and networking part also we need to discuss.
Absolutely, yeah, and we don't have any specific questions in the chat so far. Everyone is happy that we initiated this session, and it definitely helpful to many people. So I would say we can wrap up now. From my side, I can like really hugely thank Prem, Tito, Mitlesh, Zubair for taking time and attending this session as a speaker. Everyone else who joined it as a listener, thank you so much. And there was a great conversation going on in our chat. Dear speakers, if you have anything to add, please feel free to do so.
Yeah, it was really good. This was my first one live, so I was a bit nervous, but that I think Prem and you guys have really done wonderful. So that gave me a lot of confidence as well going into the next one. So thank you
Yes.
all, and thank you everyone who are a part of this.
Yeah, thanks.
Thanks, Karan.
Thank you, guys. Prem, go on.
no, we still have one more session, right? Let's have some talk for the second session.
Absolutely. Let's save some voice for the next time as well. Great. So thank you, everyone. See you next time in 1 week. We will fix the time. And yeah, have a great rest of the week. And yeah, that's it. Bye for now.
See you guys. Bye.
Bye bye.
Thank you. Bye.